This is the last section in this chapter. It's just a short section as an introduction to modeling. It doesn't go too deep into it, but we should at least take a look at how to model sets of data with lines. So we're talking about creating an equation that gives us some patterns in the set of data. And it'll allow us to predict future values. It'll allow us to give information about maybe some years that are not on the chart. And it usually starts with either a scatter plot or a data table. So if we look at these two plots, right? The first one is an exact model. So it's something that's always going up and over by the same amount. We had 6 data points, we know, because we can count 1, 2, 3, 4, 5, 6 dots over there, and everything fits exactly on that line. So maybe you're traveling at 40 miles an hour, and they take distance marks every 10 minutes, and you're always going 40 miles an hour because your car's on cruise control, and it makes an exact model. The second one is more of an approximate model. You start, you stop, sometimes you're going a little faster, a little slower, but overall, it looks like you're traveling at about the same speed, except that some of the data points don't fit on that line. In fact, none of them are exactly on that line, but they're all pretty close. So we call that a line of best fit. The book calls it an approximate model. So an exact model, every point is on that line. An approximate model is pretty close, but it doesn't go through exactly. So here is an old set of data. Person can vote in the U.S. at age 18 or over. It shows the voting age population in millions for 3 years, 2000, 2002, 2004. Does that equation model the data exactly? Well, the only way we're going to find out is by putting in the x values and seeing if we get out the population values. So in 2000, there were 203 million people that were of voting age. So the equation they gave us was P equals 3.25x minus 6297. So let's start with the first one. Let's put in a 2000 for x. So 3.25 times 2000 minus 6297. The question we're going to ask is, when we do this, do we get out 203? Or a number very close to 203. Let's try it. You can't see this, but I have a calculator here. 3.25 times 2000 minus 6297. Oh, it gives me exactly 203. So the first one works. Okay, so that equation works for the first one. Let's try it for the second one. Let's put in a 2002. So we'll get 3.25 times 2002 minus 6297. Okay, so 3.25 times 2002, and then subtract 6297. I get 209.5. And so right there, I can stop and say, no, it doesn't model the data exactly. If it did, I would get out a 211, but I don't. I get something very close to it, and I could try it for the third one. I'm sure I'll get something very close to 216, but because I don't get exactly 211, then it doesn't model the data exactly. Not every point falls on that same line. All right, this is a table of values. It shows the number of miles. Y values are number of miles, so maybe we'll make a little note. Number of miles for the Y's. Traveled by a motorhome on X gallons of gasoline. So X represents number of gallons of gas. Plot the data, be sure to label the axes. So this is going to be number of gallons. This is going to be number of miles. All right, so if I count this off, I think I have 18 dashes, 3, 4, 5. Yep. So I can actually make each of the x's span 2. So I'll make this 1, 2, 3, 4. Setting up a scale sometimes takes a minute or so. 6, 7, 8, and that'll be 9. So I go 1 through 9 on the axis, down bottom. All right, so I'm going to mark off number of miles on the y. Maybe I won't put a dash everyone's, but if I got 72, we said there were 18, so it looks like every 4. All right, so that'll be 4 miles, 8, 12, 16, 20. I'm not going to make a mark every one because it gets a lot of writing. 24, 28, 32, 36, that'll be 40. So every one is worth 4, that's 48. 52, 56, that'll be 60, 64, 68, yep, 72 is the top. Okay, do it in pencil. If it doesn't work the first time, erase it, try it again. All right, so 3 gallons of gas, there's 3 gallons of gas over here, is 24 miles. So I go over here to 324, there's a dot. All right, at 6, I get 48, so I go over to 6, up to 48, where those two grids intersect, there's a dot. 9 gives me 72, there's another dot. So 9 gallons over, 72 gallons up. Sketch the line that models the data. You're going to take a ruler out. I can't do it on this tablet, but if I can give it my best eye shot, it looks like it goes through every point perfectly. And it should head all the way down to the 0, 0 point. Look at that. Right there, 0, 0. Because if you just park the motorhome and don't turn the engine on, it's not going to take up any gas. So if you travel 0 miles, it doesn't use any gas at all. So there's a line that models the data. Find the equation of the line, interpret the slope of the line. So the slope of the line we can find by doing change in y over change in x. So maybe we'll do 48 minus 24 over 6 minus 3. That gives me a 24 on the top, 3 on the bottom. We said they're units for this. The p represents the number of miles that you traveled, and the x represents the number of gallons of gas. So 24 divided by 3 is 8. 8 what? 8 miles per gallon. Or you can use mpg, right? Miles per gallon. And that's what the slope is. Slope is 8. If I want to find the equation for the line, I can do y minus, here, let's use this. Y minus the y coordinate equals the slope times x minus the x coordinate. So I get y minus 24 equals 8x minus 24. Oh, look, the 24's drop out. We get y equals 8x. If we want to use the variables we were given in the problem, it's p equals 8x. And it should make sense that the y-intercept is 0 because we said line goes through the origin. How far could the motorhome travel on 15 gallons of gas? Well, 15 gallons of gas isn't one of the points on our table, but yet we have an equation. We have an equation that says you'll go 8 miles on every gallon of gas. So if you have 15 gallons of gas, 8 times 15. All right, we grab a calculator, we multiply 8 times 15, and we get 120. So our 120 is given in miles. We can travel 120 miles on 15 gallons of gas. All right, this one over here is just a set of data, x's and y's. It says the pairs can be modeled approximately by a line. So here it's already graphed for us. It said, could a line pass through all 5 points? Well, no, because look what happens. If I try to put a line through the first 3, I'll pass a line right through those first 3 points. But then as I keep going, now it doesn't hit those other points anymore. What if I try to pass a line through the first 2 points, right? Because it looks like that's where it changes. What if I pass a line through the first 2 points? If I pass a line through the first 2 points, it'll make that one, it'll make that one, but it won't make the ones above it, right? So one line is not going to pass through all 5 points. Question says, how can I tell without using a graph? I can find the slope. Let's say I found the slope between the first 2 points here. Right? Change in y over change in x. So 7 minus 5 over 2 minus 1. The slope of that line is 2 over 1, which is 2. Right? Let's go back to the points that we had up at the top. So maybe let's use these last points. I'll do 11 minus 10 over 5 minus 4. That gives me 1 over 1. The slopes are different. You can't have one line that has 2 different slopes. But what I could do in this problem is I could try to make a line that kind of splits the difference. So let's erase what I have here and try to draw a line that sort of connects maybe the first point and the last point, not the ones in the middle. Right. Maybe that's not the best line. Maybe I try another one. So maybe I try a line that kind of comes down like this, aims through that point, and comes down like that. So it sort of splits the difference. What are the 2 points that are closest to the line? It looks like this one and maybe that one. So on my graph, it's the one that goes through 2, 7, and then the other one is 4, 10. If you picked a different set of ordered pairs, you're going to come up with a slightly different equation for the line. That's part of modeling. You're coming up with a model that you think works for this problem. If we pick different ordered pairs, then we'll come up with slightly different answers. If you take a more advanced course like statistics or something, you'll find out how to write lines of regression, which is really what we're doing. All right, so the first thing I need is I need the slope. I need the slope between 2, 7 and 4, 10. All right, so my slope is going to be 10 minus 7. That's my change in y. 4 minus 2 is my change in x. And I get 3 halves for my slope. So you notice that the slope is not 2 and it's not 1. The way I drew it, the slope is 3 halves. All right, and then once we have the slope, then we can use point slope form to find the equation for the line. So y minus, maybe I'll use the 2, 7. So y minus 7 equals 3 halves times x minus 2. And if I want to solve this for y minus 7 equals 3 halves x minus 3. Right? 3 halves times 2 is 6 halves, which is 3. And the last step is to add 7 to both sides. So I get y equals 3 halves x. 7 minus 3 is 4. Is that reasonable? Well, look at the line that I drew. Doesn't it seem to have a y-intercept that's very close to 4? And of course, I'm drawing this freehand, so if I drew it with a ruler, it would actually go through 4. Okay, so y equals 3 halves x plus 4 looks like an equation that can model that data. It may not go through every point. In fact, mine only goes through 2, but that's what we have to model that data given what we know. And that wraps up chapter 3.